two rods are joined end to end as shown. Both have a cross-sectional area of 0.01 centimeters square. Okay, two rods, that is the copper and iron, it is joined here. Each is 1 meter long. That means the length here it is 1 meter. Okay. One rod is copper with resistivity of 1.7 into 10 power of minus 6 ohms centimeter. The other is iron. This is the copper and this is iron. Its resistivity is 10 to the power of minus 5 ohms centimeter. How much voltage? It is VOLTAG. It is V is missing. Voltage is required to produce a current of 1 ampere in the rods. Okay, options they are given here. Then the data, whatever they are given, we will write here first. That is length is equal to 1 meter. Length is 1 meter. And the cross-sectional area, that is A is equal to 0.01 centimeter square. If I am going to convert this one into the same unit, that is meters, then it becomes 0.01 divided by 100. It becomes 10 to the power of minus 4 meter square. And the resistivity they are given here, that is rho copper, the value is 1.7 times 10 to the power of minus 6 ohms centimeter. If I converted this one as in terms of meter, then this becomes 1.7 into 10 to the power of minus 8 ohms meter. Similarly, the resistivity of the iron Fe is equal to, they are given 10 to the power of minus 5 ohms centimeter. If I convert this one in terms of meter, that is 10 to the power of minus 7 ohms meter. Then we know that the resistivity of the resistance of the copper rod, it is given by RCu is equal to rho Cu upon 1 upon A. Similarly, for the iron, Rfe is equal to rho Fe times 1 upon A. Voltage, the value of the voltage we know. According to this, the value of the voltage, V is equal to, we know that I times R, where I is equal to current, we need to produce it as 1, and RCu plus Rfe. Then if we substitute the values, it becomes, we can write this one as rho Cu plus rho Fe, copper and iron, then terms of 1 by A, then it is equal to 1.7 into 10 to the power of minus 8 plus 10 to the power of minus 7 times 1 upon 0.01 into 10 to the power of minus 4 volts. Then simplify this one, we get the answer 10 to the power of minus 7. If I am going to take the common, it becomes 0.17. Instead of 1.7, I will write 0.17 plus 1 into 10 to the power of, this 0.01 is nothing but 10 to the power of 2. This is under the denominator, we can take it as minus 2, and 10 to the power of minus 4. This will come into the numerator. This becomes 10 to the power of 6. Then we get the answer. Here 10 to the power of plus 6 is there, 10 to the power of minus 7 is there. Then our answer is, we can write it as 1.17 into, this is 1 plus 0.17 is 1.17 into 10 to the power of minus 1. If I remove this 10 to the power of minus 1, then I can write in terms of decimal, the voltage is equal to 0.117 volt. Then option D is the right answer here.